Hello everyone. In this video, we are going to do analysis of algorithm part 2. I've already discussed some starting of analysis, how to analyze the time and space, or what is time complexity and space complexity in part 1. So let's see. I've taken some examples. But first of all, let me again give you very briefly what is the time complexity of an algorithm. So the time complexity of an algorithm or a program is basically the compile time it takes to compile that program added with the runtime. Okay, so but we are not very much interested in the compile time, or we are not very much bothered to calculate the compile time. Why is it so? Because the program is only going to compile once. Okay, after it is compiled, we can run it many times, and we need to calculate the runtime every time, or we need to know how what at how much maximum, what is the maximum time the a particular program may run. Now, why it is important to calculate this runtime but not the compile time? Because during the running, the input size may increase or decrease. So depending on the input size, what can be the input size? Suppose if I represent the input by n, then sometimes input can be 10, sometimes input can be 100 numbers, sometimes input can be 10 to the power 4, like this. It may increase or decrease. Okay. So for example, I have a problem to add 10 numbers or add n numbers. Then sometimes 10 numbers may come, sometimes 100 numbers may come, or sometimes 10 to the power 4 numbers may come. So I need to know, depending on the input, what is the time taken by our algorithm or by our program. Okay, so I have just here written a simple code of adding a number, and I have to calculate the time complexity. So this is the question also here, compute the time complexity of this code. So uh, now if you see closely, also uh, the major time taken by a program is in the loops. Okay, this is a unit time. I've just declared s is equal to 0. This will take unit time. So this is not of any consequence. But in the loops, we have to calculate the time which is of consequence. So this loop is running from 1 to n. Okay, so this loop is running from 1 to n, and there is no exit condition in between. I'm just going to add some numbers in s. Okay, it is just going to add up. So what is the time complexity here? The time complexity is dependent on n. Okay, depending on what is n can be 10, 100, 1000. Okay, and we are going to add up the numbers. So we say the time complexities of order n. Okay, so like this, there are these 6 basic uh, time complexity or some mathematical identities, or we can say functions, or through which we can represent the time complexity. The first one is a constant function called as c. Okay, so there is something called as log n, there is something called as n, okay, and there is something called as n log n square, cubic function like n cube, factorial n. We can represent our complexity like this, log n, something like this. Okay, so let's first discuss what is a constant function. So here this is a constant function. Now why we are saying this is a constant function? Because we already know how many times this loop is going to run. This loop is going to run from 0 to 100. Okay, and we are just adding some number I plus 1. Okay, and it is just going to print. So because we already know uh, that this is going to run 100 times, there will be no fluctuation in the running time. That is why we have said that this is a constant function. Next, there is a logarithmic function. Now, this is a very important function, and you will encounter this function here and there in many algorithms, in many types of computing the time complexity of the algorithm. Why is it so? Because it is very common. Why is it so common? Let's see. Let me write this again here. For I is equal to 1, I less than equal to n, and at what rate I is running? I is incrementing twice, and inside we are printing something. So the question is, how many times this for loop is going to run? What is the time complexity of this program? Okay, so when I is 1, we are definitely going to print one time. Okay, print one time. Now what will be the value of I? Now the I will become 2. We have not assigned anything to n here. So let's just assign n is equal to be 100. Okay, so I is equal to 2. 2 is less than 100. So again it is going to print the second time. Now what will be the value of I? I will become 4. Again it will print the third time. Now I will become 8 because of this. Okay, 2 into I. Again it will print the fourth time. Then I will become 16. Again it will print because 16 is less than 100. Then 32, 32 is less than 100. 64, it is still less than 100, 7 times. But after, let's say, if this becomes 128, okay, but the 8th time, it will not print. It will just print 7 times. Okay, this much time only it will print. So if you calculate, then it turns out that its time complexity is log n to the base 2 basically, or we can say its time complexity is of order log n. Okay, because of this. Why we are saying base 2? Because we are multiplying it with 2. We have multiplied it with 4, its time complexity would have become log n to the base 4. Okay, like this we calculate this kind of logarithmic transition. Okay, now moving on, the third function is a linear function. Why is it a linear? Because the order is of n, the time complexity is of order n, because on the number of input this code will run. If n is 10, the order is going to be 10. If n is going to be 100 at runtime, the order is going to be 100. If it is something else, then the order becomes that. Okay. But in the previous question, n was 10 or n was 100, but the time complexity was log n because of it was not linear. It was incrementing twice at the rate. Okay. So this is a linear function. Then moving on, then we have something called as n log n. So this program time complexity is n log n. How? The first for loop, if you see, the first for loop is 0 to n. So this is going to run n times. And the second for loop, as we have seen in the second example, log example, it is running by 2 into j. So this will run log n time. So that is why the total order will become n log n. Okay. Then the fifth part, the quadratic function. Here the order is n square. Now how it becomes n square? Because this will run n times, this first for loop, and inside this for loop is again going to run n times. So that is why the order becomes n square. And in the sixth part, we have a cubic function. Cubic function means the order is going to be n cube. Why? Because this is running n times, this is running n times, and this is running n times. So combined, see, they are running like this. So these are like this. We can calculate the running time of our program. We do not have to be dependent on a machine, and we should not calculate it with the help of a machine. We should be able to just see and check what should be the time complexity, as I have mentioned before, because there can be a core i3 machine, a i7 machine, a supercomputer, and all will give different times for the same program. So that is why we have to calculate it like this, what we have just seen. Okay, so thank you for watching this video. We'll again meet in the next video. Thank you.